derivatives of inverse trig. Okay, we did review inverse trig functions in the beginning, but let me refresh what was done back then. So what does it mean by sine inverse of, say, 1/2? An inverse function is a function obtained by flipping the input and output, right? So if you say this is equal to x, then this is just another way of saying that sine of x is equal to 1/2. See, in this format, x is the input and 1/2 is the output, right? What does the inverse function do? It switches the input and output, and that's what you get. So if we solve for x, we get the inverse function of 1/2. However, if you look at the graph of the sine function, that's the sine graph, right? There are two places that it gives you 1/2, and actually more if you remember that this is a periodic function. You have actually infinitely many places where sine x gives you 1/2. So which of these x's are we talking about when we are looking for this value x? And the answer is that because the inverse function wouldn't be a function if you allow the signs to have everything as the domain. You want to restrict the domain from negative pi over 2 to positive pi over 2. And if it's restricted, then for any given value between negative 1 to 1, there's only one unique x that solves such an equation. Right? So the inverse function, sine inverse function, is really the inverse of the restricted sine function. It's a sine function restricted to negative pi over 2 to pi over 2. Okay, then you probably remember which one this is. It's like small, medium, large. So it's the 30, 45, 60 special angles, and among them, it's the smallest one, which is 30 degrees. Which in radians, it's what? 30 degrees is pi over 6. So we know that sine inverse of 1/2 is pi over 6. Okay. All right. So that was a very short review of the inverse trig functions. If you are not so sure about inverse functions, you probably need to review more when you get home or get back to the dorm. All right. So now let's try to think about the following question. What is the derivative of sine inverse of x? Let's think about this question. All right, first of all, we're going to do something very similar. We're going to say, let's say sine inverse of x is equal to y. Now, what does that mean for the sine function? Sine of y equals to x. Now, since we're trying to find the derivative of sine inverse of x, what we're trying to do is we want to find y prime when you set y as sine inverse of x. So, given this, our goal is to really find out what y prime is. That's the question. Well, this is just the implicit differentiation that we just learned, right? So let's try it. If I differentiate the left side, also the right side, y is nested inside, so you differentiate the outside function, which is cosine. Pull the inside function out and you differentiate. And you differentiate x, you get 1. And therefore you get y prime equal to 1 divided by cosine y. This is almost okay, but kind of falls short to our original original goal, because y was something we introduced in order to differentiate. And we got the answer in terms of y. The original question was only proposed in terms of x, so it would be nice if we can turn this answer in a form of x. So let's think about how that can be done. Okay, so here's how you think about it. You have sine of y equal to x. Now think of x as x over 1. And using SOHCAHTOA, what is sine equal to in SOHCAHTOA? Opposite over hypotenuse. So you're going to say you have a right triangle whose angle is y here, and at the opposite of y, what should I put here? X. On the hypotenuse, what should I put? 1. Now what will go here? You can use the Pythagorean theorem, right? So if I just say this is a, then a squared plus x squared equals to 1 squared. A squared plus b squared equals to c squared. That's the Pythagorean theorem, right? And therefore a squared is 1 minus x squared. And take the square root, you get square root of 1 minus x squared. So that's your a. So then I can replace this a by square root of 1 minus x squared. And that's perfect because from that picture I can figure out what cosine of y is. What is cosine of y from that picture? It's adjacent over hypotenuse, right? So cosine of y is square root of 1 minus x squared divided by 1. But division by 1 doesn't do anything, so that's what you get. And therefore the answer is that sine, so final answer is that sine inverse of x prime gives you 1 over square root of 1 minus x squared.
So we always have to put it in
Yes. I mean, sometimes you don't have to use the Pythagorean theorem, but in most cases, if you have your answer in terms of y, and it's cosine of y or tangent of y or sine of y, if something like that appears, then you want to draw a triangle like this using SOHCAHTOA. Apply the Pythagorean theorem to figure out the other side, and that can help you in figuring out what that is.